All right. Good morning, everyone. So today we'll continue our discussion about, or actually, we'll start our discussion about axiomatic set theory. So we will try to apply what we learned last time in a redevelopment or in a reconstruction ng set theory na I think you have already seen in AMAT 19 or MAT 20. Tama nga ba? Nag-work na kayo dun with sets, basic operations with sets. And other things. And I think you have, since you are math majors, probably you have also encountered sets in some other courses that you have taken, because sets or set theory is one of the most encompassing subjects in math. So kung papansin niyo or mapapansin niyo in your future courses, halos lahat sa kanila ay gumagamit ng notion ng sets. Meron tayong mga objects, nilalagay natin siya sa isang collection that is taken to be a whole, and then we usually perform some operations on these collections or on these sets. And this is predicated on the notion of set theory. Okay? Pero ang gagawin natin dito, i-reconstruct natin yung set theory na natutunan nyo or nakita nyo before. I understand that in AMAT 19 or in Math 20, medyo crude o medyo primitive yung pagkakadiscuss ng set theory. Hindi niyo siya tiningnan from an axiomatic or a mathematical or a technical mathematical point of view, kasi parang siguro nagsimula lang kayo noon sa undefined terms. Sinabi niyo na ang set ay isang collection ng objects na tinatawag nating elements. So those are your undefined terms in this discipline of or in this field of mathematics. Okay? So tapos nung natutunan niyo itong dalawang undefined terms na to, dumiretso na sa examples ng sets. So meron kayong roster method, meron kayong set builder notation para i-describe kung anong itsura ng isang set. Tapos nagpunta na kayo sa operations on sets. And you were not introduced to what are the axioms or the basic assumptions that govern this field of mathematics. Pero natutunan natin from our meeting last week ng any mathematical discourse should have a formal foundation. So yun nga yung sinasabi natin, dapat pag meron kang binubuo na isang theory sa loob ng math, dapat nagsisimula ka sa undefined terms, and then right after those, meron kang mga self-evident truths or mga truths na or mga statements na kung hindi man sila self-evident, ay ina-assume natin sila for the sake of what is to follow. Parang sila yung ground rules. So sila yung pinaka-foundation ng mga nung discipline na bubuuin natin. So sila yung axioms, hindi natin sila pinuprove, ina-assume natin sila na totoo. And last time we have seen several desired properties of an axiomatic system. Number one, the system should be finitely describable. So dapat finite lang or kakaunti lang yung axioms na gagamitin mo. Second, we want our axiomatic system to be free of contradictions, walang internal contradictions dun sa discipline. Either the axioms are not contrary to each other or not contradictory to each other, or they will not give rise to theorems that are contradictory to each other. And then we also want the system to be complete, meaning we should be able to deduce or to prove all statements in our in our logical discourse. Tapos, meron pa bang pang-apat na desired property ng isang axiomatic system? Can anybody remind me? May pang-apat pa ba? Finitely describable, no contradictions, so consistent. Tapos, and then the last one ay independent. Dapat yung mga axioms natin, no axiom should be derivable or should be provable using the other axioms. So yun nga yung naging istorya dun sa fifth postulate ni Euclid, that people are trying for hundreds of years to prove that actually for at least 1,000 years na i-prove yung fifth postulate mula dun sa unang apat na postulates na binuo or sinabi ni Euclid sa kanyang work na The Elements, okay? Which reminds me, there's one of you who asked a good question. Siguro this is one one flaw of my example last time. Gumamit ako ng terms na axioms and postulates kasi ito yung traditional na ginamit ni Euclid before. In the pre-modern times, nung time ni Euclid, magkaiba yung tingin nila sa axioms at saka sa postulates. So yung axioms nung time ni Euclid, ginagamit lang nila para sa mga self-evident truths. So, self-evident truths. Ito yung mga ito yung mga statements na alam na natin na totoo from intuition. They are so basic that they don't need a proof. And usually, these axioms encompasses or these axioms encompass different areas of mathematics. Kung makita nyo, number one, things that are equal to the same thing are also equal to one another. That's what? That's the transitive property of equality. Number two, if equals are added to equals, then the wholes are equal. So ito yung addition property of equality na nag-work sa kahit na anong field of mathematics. Mapa-analysis man yan, mapa-geometry man yan, or mapa, ano pa bang field ang pwede? Algebra, calculus, or geometry. So, laging totoo itong mga axioms na to. So, yun yung gamit nila nun. So, these are self-evident truths. Alam na natin na sila ay totoo. Hindi na sila kailangang i-prove. They are assumed for the entirety of mathematics. Or at least a version of them exists in other branches of mathematics. Compared to postulates, ito yung mga statements that Euclid assumed for the sake of what is to follow. Okay? So, hindi sila ganun ka self-evident. So, sila yung mga statements na kailangan niyang i-assume para makabuo ng isang brand ng geometry. So parang ito yung pinili niya to be the building blocks of the geometry that he is trying to build. Meanwhile, the axioms are something that is given to begin with. Okay? So parang existing truths na yung axioms, yung postulate si Euclid ang nag-isip na, sabi niya lang, sige, mag-iimbento ka ng geometry, dapat ganito yung properties na nag-exist dun sa geometry na yon. So, for instance, he wants through any, or you can draw a straight line passing through any 2 points. So, pwede naman yung sinabi na any straight line should have at least 3 points. Okay? So, pero ang pinili niyang postulate dun sa kanyang geometry na kinonstruct ay sa pagitan ng dalawang points, laging may isang straight line kang may drawing. Okay? So, in this sense, so magkaiba yung axioms sa postulates. Pero during the modern times, the use of the words axioms and postulates are interchangeable with each other. So parehas na yung tingin natin sa axioms at saka sa postulates. Okay? Noong panahon nga lang ni Euclid, meron silang pinagkaiba. Alright? So, okay. Now, going back to our lesson at hand, medyo na off tangent ako doon. Pero the idea, again, as I've mentioned, we will painstakingly reconstruct set theory. Probably you have used this before in your previous courses, but we will develop it in the formal way, in the way that was proposed by the modern day mathematicians in the 16 or 1800s. Iko-construct natin siya using axioms. So, ililay down natin yung mga axioms that govern set theory, and from there, we will develop the theorems that are very useful, and para magkaroon tayo ng idea or magkaroon tayo ng solid foundation with set theory, which you will encounter in one way or another in all of your mathematics courses. Okay. And then there are two brands of set theory. Number one is the Cantorian set theory, and the next one is the modern one, which is what we will use, the Zermelo-Fraenkel set theory. But these two set theories, quote unquote, are not different from each other. Makikita nyo lang yung transition. Bakit kailangan nating medyo baguhin ng konti yung set theory na inimbento ni George Cantor. Okay? Pero yung parehas na set theory na to, ito yung ginagamit natin mula pa nung AMAT 19 or Math 20. Okay? So let's start with Cantorian set theory. Others call it the naive set theory or the primitive set theory. Yung iba, intuitive set theory. Okay? So it was developed in 1870s by the German mathematician George Cantor. Nung nag-work siya with trigonometric series and series of real numbers, napansin niya na kapag ka pala meron akong dalawang finite sets, pwede kong i-compare silang dalawa or pwede kong i-pair yung elements nila kung magkasing dami sila ng laman. And an interesting question came to Cantor. Paano kaya kapag meron akong infinite set of numbers? Paano ko mako-compare yung dami ng laman ng infinite set of real numbers or of numbers? And this led him to develop a concept of transfinite numbers to describe the magnitude or the size of counting numbers. And for him to formally develop this concepts of transfinite or infinite numbers, kailangan niyang i-construct yung set theory. Okay. Now, in his development of set theory, meron siyang ginawang or meron siyang undefined terms. Unang undefined term na ginamit niya ay set, of course. So he mentioned that a set is any collection into a whole of definite, distinguishable objects of our intuition or thought. So parang ang set ay isang well-defined collection of objects. Okay? And then the objects are called elements or members of the set. So ito yung unang dalawang bagay na kailangan natin sa pagko-construct ng set theory, at least in the point of view of Cantor. Meron kang set, collection of objects, tapos meron kang elements. Sila yung mga objects. Hindi natin pwedeng gamiting formal definition yon ng set saka elements kasi pag sinabi mong set, ano ba, sabihin natin na set is a collection or a well-defined collection of objects. Ano ba ang ibig sabihin ng collection? Ang ibig sabihin ng collection, well, aggregation. Or ano pa ba? Isang grupo ng mga elements o ng mga objects, right? Pero if you go on this exercise of giving synonyms or trying to define set, babalik tayo dun sa set being a set. But that's not a good definition because we don't want to define a term using itself or using another undefined term. Pero sa sets, ang main keywords dito ay collection at saka objects. Pero yung objects, paano mo i-define yung objects? Objects are things that belong to a set. So magiging circular naman ngayon yung definition. That's why this paragraph here gives us an intuitive notion of what a set is. But we cannot consider this as a formal definition of a set nor of an element. Kasi nga, intuitive notion lang siya. So, for the sake of constructing set theory, accept na lang natin na hindi natin kayang i-define itong mga objects na to. So, sila yung mga primitive terms dito sa set theory. So again, a set is a well-defined collection of objects, or in the language of Cantor, it is any collection into a whole of definite, distinguishable objects of our intuition or thought. So kumulekta ka ng mga bagay, tawagin mo silang elements. Tapos, i-consider natin as a single entity yung collection na yon, yun yung tinatawag natin na set. Okay? And you will see that the very definition of a set is hinged on the membership of that set. So parang ang central idea sa set ay nagre-revolve sa ano yung mga laman ng sets na yon. Okay? Now, as a matter of convention, we will use capital letters to denote sets and lowercase letters to denote the elements of the sets. So, or pwede naman yung isang element ng set ay i-label natin or i-index natin by putting subscripts to them. So, we can say, halimbawa, the set A or the capital A is equal to the set containing x sub 1, x sub 2, x sub n. Tapos naka-enclose siya in curly brackets. Okay? Now, convention lang naman to, so pwedeng along the way magkaiba-iba tayo, pero ito yung default convention natin. To make it clearer na kapag ka sets yung usapan, capital letter yung gagamitin natin. Tapos, pag elements ng set, usually small letters yung ginagamit. Or sometimes with subscripts or with index. Pero not always the case. One interesting case is walang nagpe-prevent sa atin so far na maglagay ng sets sa loob ng isa pang set, right? So we can also take a set to be a collection of sets. Halimbawa, set A1, set A2, set A3, and so on. Pwede rin siya. Okay? So, but again, ito lang yung, if possible, ito yung gagamitin nating convention. Okay? So, and then this is an enumeration of the elements of the set A. Kasi nga, ang konsepto ni Cantor ng sets ay nagre-revolve lamang sa membership ng set na yon. Okay? And by the way, a description of a set this way is called the roster method, wherein we just enumerate all the elements of the set, put them together inside curly braces separated by commas. Okay. Now here are some examples of sets: the set of the past presidents of the Philippines, the set of condiments, the set of the first 10 prime numbers, the set of even numbers, the set of points on a unit circle. Okay? So, basta kaya nating ma-distinguish without any ambiguity kung ang isang element ba ay nagbe-belong dun sa collection na yon, then that collection can be considered as a set. Okay? Now, can anybody give me an example of a set aside from these 5 examples? You can give any set that you'd like. Pwedeng formal note, pwedeng informal description. Pwede rin namang roster method kung gusto nyo. Volunteers? Okay, go Mary Rose.
Sir, set of all even numbers.
Okay, thank you, Mary Rose. Medyo technical yung example niya. But yeah, that's correct. The set of all even numbers. Who else? Sino pa gusto magbigay ng isang example? Oh yes, Emerson.
The set of all primary colors.
Okay, set of all primary colors. Anong ano niya? Roster method. Roster description niya. Siya yung set containing ano nga bang primary colors? Red, blue, and green. Ano bang pangatlong green, no? RGB.
Green, RGB pa.
Okay, yeah. Napaisip ako doon ng konti. Alam mong maaga pa, no? Or, yellow nga ba? Oh, yeah, yellow, yeah. Red, blue, and yellow. Thank you, Victor and Esther. Yeah, maaga pa talaga. So, hindi pa nagre-register yung primary colors. Pero thank you. So, that's right. And then Esther is suggesting the set of all presidential candidates for the 2020 elections. Well-defined na ba yan, yung set of all presidential candidates as of now? Technically, meron, pero baka magkaroon ng changes in the following days. Let's see what will happen in this sarsuela called Philippine elections. Pero, yeah. Pero yun yung problema, dapat ma-remove natin yung ambiguity. So, pwede sigurong sabihin ni Esther, yeah, set of all presidential candidates for the 2022 elections as of today. So, yun yung idea. Dapat walang ambiguity. So, hindi ko rin pwedeng sabihin na the collection of all handsome or pretty Math 101T students ay isang set. Kasi hindi well-defined yung criteria what it takes to be pretty or handsome. So, dapat walang ambiguity doon sa pagdetermine if an element belongs to a set or to the collection or not. So, yun yung sinasabing well-definedness. Pag binigyan kita ng isang object, you can tell me without the shadow of a doubt that that element or that object belongs to the collection. Yun yung tanging gusto ni Cantor dun sa membership ng set niya. So dapat walang ambiguity sa pagdedetermine ng mga laman ng sets niya. Alright? Now, Bakit ang daming hininging okay, magkaiba pala yung example 13 and 14. But now, maybe we can proceed to introducing some notations. Pero I think nagamit na natin yung iba dito when we talk about logic in the first half of the semester. We use this symbol to denote membership. So we read this as X is an element of A. That means X is one of the members of the set A. All right. And then if we are trying to describe multiple elements of a certain set, then we can just separate them with a comma or with commas and put an element of A after. So kapag ka medyo merong mahabang series of elements, ibig sabihin lang yan si x1 ay na kay A, si x2 ay na kay A, at hanggang kay xn ay na kay A pa rin. Alright? So membership or this is used to show the relationship that whatever is to the left is an element of the one that is in the right. Okay? And then if we know that a certain object, say X, is not a member of the set A, then we use the same symbol, this epsilon looking symbol, but with a cross or with a slash. So ibig sabihin nito, si X ay wala kay A. Okay? So ito yung mga basic notions ni Cantor dun sa ini-invention niyang set theory. Okay? And then of course, he said na, okay, meron kang undefined terms, meron kang mga notations. It's now time to lay down the rules or the foundations of the theory that we are developing. So para siyang, kumbaga sa political science, para siyang yung constitution ng isang bansa. Remember, the constitution is the fundamental law of the land na lahat dapat ng laws na ipapasa ng legislative body, say ng Congress, ay dapat hindi contradictory dun sa Constitution. Alright? Kundi sasabihin ng Supreme Court nila na this is an invalid law because it violates the Constitution. So kung may Constitution sa policy, sa math naman may axioms. Lahat dapat ng theorems manggagaling or susunod sa mga axioms na to. And in Cantor's development of set theory, meron siyang tatlong axioms na ginamit. Okay? The first one is the axiom of extension, or what other books refer to the intuitive principle of extension. Ang sabi ng intuitive principle of extension ni Cantor, two sets are equal if and only if they have the same members. Tapos magiging apparent pa rin dito yung bias ni Cantor sa pag-develop niya ng set theory that is basically determined by membership. So sabi niya, ang dalawang sets ay equal kung at kung lamang sila ay parehas ng laman. Okay? Now, as a notation, we use the equality symbol even for sets. So equality is also a set relation. We say that A is equal to B even only if all members of A are in B and all members of B are in A. Kasi if and only if nga yung ginamit and they have the same members. So basically, if we want to show that two sets are equal, we need to show that every element in the first set is in the second set and all elements of the second set are in the first set. Yun yung intuitive principle of extension. Okay? If there is a member of one of the sets that is not in the other, then we say that the first set is not equal to the second set. Or in the case of sets A and B, A is not equal to B, written this way, the equal sign with a slash on it. Okay? Now let's see. Example 15. So we consider the set containing 1, 3, and 5. Okay? Sila yung first three positive odd integers. And then let's consider the other set containing 5, 3, 1. So pag inanalyze natin si 1 na nandun sa first set ay nandun sa second set. Si 3 na nasa first set, nandun din siya sa second set. Si 5 na nasa first set, nandun din sa kabilang set. And you can also do it in the other way around. Check if all the elements of this set is in the first set. And since that will be true, then we say that this set is equal to this set. All right? Now, isa sa mga implications or consequences ng intuitive principle of extension ay hindi nagmamatter yung ordering sa sets. So kahit pag jumble-jumblein natin yung elements ng isang set, we will always get another set. Kasi nga, sabi ang requirement lang ng principle of extension, equal sila kapag kaparehas sila ng laman. It doesn't matter kung ano yung ordering ng mga laman nila. Okay? So that's why you can think of sets as an ordered list of objects. Kasi nga, by the principle of extension, hindi nagmamatter yung pagsusulat o yung order kung paano natin isusulat yung set. All right? Now, example 16 gives us one interesting example. So in this case, we have a set X, which contains the set containing 1, 2, the set containing 2, 3, and the set containing 1, 3. So ito ay isang set na ang laman niya ay sets. Dun sa definition o dun sa intuitive notion ni Cantor ng sets, hindi naman niya sinabi na bawal ang sets magkaroon ng laman na sets din. Alright? Ang sabi niya lang, ang sets ay collection ng mga objects. Kahit anong objects, anything under the sun and beyond. Pero, ibig sabihin, pwede rin pala yung set magkaroon ng laman ay sets din. Okay? So, katulad nitong set X. Ito yung laman niya. So if you want to put a set inside another set in roster method, dapat curly braces pa rin yung ginagamit nyo all throughout para i-denote na isang set yung nasa loob. Huwag niyong palitan yung curly braces by say parentheses or angular brackets kasi nga sa set theory, ang brackets ay ginagamit natin to enclose members of a certain set. Okay? Now, we will see, or it is apparent, that this set X is not equal to the set 1, 2, 3, which we call Y here. Kasi, halimbawa, set containing 1, 2, ito yung unang laman ng set X. So para ma-distinguish siguro yung laman ni capital X, pwede nyong i-imagine na wala yung outermost pair of brackets or braces. Okay? So ibig sabihin, pag tinanggal ko yung outermost pair of braces, ang matitira na lamang ay yung mga elements talaga ng sets. So with that in mind, yung unang element ni capital X ay set containing 1, 2. And can we see that in the set capital Y? We can't, right? Kasi ang laman lang ni capital Y ay number 1, number 2, and number 3. Wala sa kanya yung set containing 1, 2. And since we have found one element of capital X that is not in capital Y, then by the principle of extension, the set X is not equal to the set Y written this way. Okay? All right. With that in mind, let's answer exercise 7. The sets A containing the set containing AB and the set B to be the set containing A and B, they are not equal. Bakit? Any volunteer? Yes, Victor?
Because sir, set A contains the set of AB, and that's only one element. And set B is two elements, which is A and B.
Okay, thank you, Victor. So nice argument, though hindi directly hindi niya directly ginamit yung axiom of extension, but perhaps one consequence of the axiom of extension. That's fine. So nakita natin dito na for sure, merong laman si set A na wala kay set B. Kasi si set A, iisa yung laman. Ang laman niya lang ay yung set containing AB. Remember, sabi ni Cantor dun sa intuitive notion ng set, ang isang set is taken to be a whole. So you're talking about a collection. So yung set containing AB na nasa loob ni set A, considered as a single entity yan. Okay? So isa lang talaga yung laman ni set A. Set containing AB yung laman niya. Kasi nga ang set ay isang definite whole. So hindi siya, treated na siya as a single object. However, the set B contains two elements. So for sure, magkakaroon ng elements si A na wala kay set B. So they are not equal to each other. And let's see example 8. Ito bang dalawang sets na to ay equal sa isa't isa? Yes, Marnie?
Yung dalawang set po is equal po sa isa't isa. This is because po, kagaya nga po ng sabi ng axiom of extension, kapag po equal or exactly the same po yung elements ng sets equal po sila. Nasasabi po natin na same po yung elements kasi po yung first two members exactly the same naman po. Tapos yung last members naman po ay same din kasi nga sabi niya nga po kanina, ordering doesn't matter po.
Okay, perfect. Thank you, Marnie. Yeah, because you can do an exhaustive check. Tama si Marnie. And by set containing 1, 2, that's the first element of the first set. Kaya lang dun sa second set, meron tayong set containing 2, 1. However, the set containing 1, 2 is the same as the set containing 2, 1 because these two sets contain the same members. All right. So, and then you can do that for the other two elements and do it vice versa. Then we can conclude by the principle of extension that the two sets are equal to each other. Okay. Now you will see that the principle of extension kind of give bias to the roster method. Kasi nga ang batayan natin ng equality ng sets ay dapat yung laman ng isa ay nandun sa kabilang set and vice versa. So kaya mas madali siya makita kapag naka-roster method. However, magkakaroon tayo ng problema kapag infinite na yung set wherein we cannot exhaustively list all of its members. Okay? Pero the idea here is the principle of extension provides us a way on how to prove that two sets are equal on a logical point of view. Hindi natin kailangang i-compare isa-isa yung mga elements. We can do it formally by looking at or by proving that if X belongs to A, then it necessarily follows that X is in the second set, B. And there's another part, if X is in B, then X is in A. So kung matatandaan nyo yung axiom of extension, if and only if siya. If and only if the members, if and only if they share the same members. So yung condition na yon ay isa pa ring conditional statement. So ibig sabihin, twofold yung proof natin. Kung si X ay na kay A, dapat mapakita natin na si X ay na kay B. And also, kailangan kung si X ay na kay B, dapat mapakita rin natin na si X ay na kay A. So may dalawa tayong kailangang i-prove. Now here's a nice example of how to do that. Okay, so we consider A to be the set of all positive even integers, and there would be infinitely many of them. So the roster method or an exhaustive listing of the elements is impossible. And B is the set of all positive integers, which can be expressed as the sum of two positive odd integers. So in the way they are phrased, mukhang magkaiba yung set A at saka yung set B kasi magkaiba yung description nila. Si set A, lahat ng even. Si set B, lahat ng integers or positive integers na pwedeng isulat as the sum of two positive odd integers. And then, sabi natin, kaya palang mapakita na si set A ay equal kay set B. And following our remark earlier, there are two components to this proof. We need to show that if X is in A, it necessarily follows that X is in B. So dapat kapag siya ay even integer or even positive integer, dapat masulat natin siya as a sum of two positive integers. And we also need to do it the other way around. Para makompleto na yung laman ni B ay na kay A din, kailangan nating ipakita na kapag siya ay expressible as a sum of two positive odd integers, dapat siya ay even. Okay? Now siguro let's analyze it formally. We say ang mga laman ni A ay yung mga kaya nating isulat as 2k for some positive integers k, right? So yan yung characterization natin sa mga positive even integers. Sila yung mga 2 times a positive integer. And then si B naman, ang laman niya ay lahat ng integers na kaya nating isulat na odd number plus another odd number. So O1 and O2 are both odds. And then we need to show the equality of these two sets. All right? Now let's do the first thing. Okay, we will assume that X is in set A. Then by our characterization earlier, we say that X is a positive odd number. If it positive even number, if we can write it as 2 times another positive integer. And then from here, we want to show that x can be expressed as an odd number plus another odd number. The idea lang ay existence. Kailangan nating mapakita na merong paraan para masulat si x bilang odd number plus another odd number, when we know that x takes the form 2 times m. At hindi naman kahirapan yon, pwede niyong piliin na isulat si x as 2m minus 1 plus 1. Okay? So remember, 2m minus 1 is an odd integer because it is even minus 1. That's our characterization of odd numbers. And then 1 is obviously odd. And then when we add these two guys, we will get back 2m, which is equal to x. So here we have provided a decomposition of x into two odd positive integers. Okay, and that's perfectly fine. So that completes the proof or half of the proof. So napakita na natin na kapag ka siya ay nasa set A, na kay set B rin siya. Okay? Just note that this expansion or this decomposition is not unique. You could have chosen another way to write it. Okay? Pwedeng 2m minus 3 plus 3. Pero kailangan yung i-argue kung bakit naging odd si 2m minus 3. Pwede nyo sabihin na si 2m minus 3 ay odd kasi yung 2m minus 3, pwede kong isulat na 2m minus 1 minus 2m minus 2 minus 1. So even minus 1 pa rin siya. But I guess this is the simpler way to decompose 2m as the sum of two odd integers. Right? Now we'll complete the proof by doing the other way around. Let's assume an arbitrary element of capital B. Si B ay set ng lahat ng integers sa kayang isulat as a sum of two odd integers. Then we can say x takes this form. 2p minus 1, that's our first odd number. And then our second odd number is 2q minus 1. Okay. Now where p and q are both positive integers. Now the idea here is, so ito yung mga members ni, ito yung isang generic member ni capital B. Kailangan nating ipakita na ito ay kayang ma-simplify as 2 times another positive integer para ma-conclude natin na even siya. Alright? And true enough, pwede nating i-perform yung algebraic operations dito. So you'll have 2p plus 2q minus 2, which you can factor this way. It's 2 times p plus q minus 1. And since p plus q minus 1 is a sum of positive integers, then in turn it is also a positive integer. So that means x is twice a positive integer. So ibig sabihin si x is necessarily even. Okay, so that proves that if you have a sum of two odd numbers, then it is automatically an odd integer. And so by the axiom of, or by the principle of extension, we can say that A is equal to B. All right. Now, I leave to you guys exercise 10. Pag-isipan nyo kung paano nyo pwedeng ma-prove yung exercise 10. Equality of sets, medyo technical nga lang siya kasi you are working with inequalities for both of these two guys. Okay? Now, so that's the essence of the principle of extension. Tapos, ito rin yung ginagamit natin na pa-prove na equal yung dalawang sets. Though, hindi na natin usually ine-emphasize na ginamit natin yung axiom of extension para mapakita na or kung bakit natin na-conclude na si A ay equal kay B. So, pero at the back of our minds, there is the axiom of extension that allows us to conclude that using these two proofs or these two parts of the proof na si A ay equal kay B. All right? But this is just the first of Cantor's set theory. Now, to more efficiently handle sets that have many elements, in particular those that have infinitely many elements, inintroduce ni Cantor yung pangalawa niyang axiom, which is called the intuitive principle of abstraction. Sa intuitive principle of abstraction, gumamit siya ng isang formula na tanging masasatisfy lamang ng mga elements ng set na yon. So he is using here a property or a formula that could be used as a criterion to determine whether an object is an element of the set or not. So ibig sabihin sa principle of abstraction, parang instead na ipagpilitan nating isulat siya in a roster method, pinropose ni Cantor na sige, pwede siguro na magbigay lang tayo ng isang distinguishing property na ang makakasatisfy lamang ay yung mga elements ng set. At lahat ng elements ng set ay nakakasatisfy ng property na yon. So we call it a formula P about X. This property is always said to be able to define a set because the members of A are exactly and only those objects that will make the statement P of A to be true. And this gives rise to what we learned before as the set builder notation for a set. So here, the principle of abstraction says we can write a set instead in a roster fashion. We can write it as the set of all x's such that x has the property P. Okay? So ito yung isang paraan ng pagsulat pa ng set, and it is predicated on the principle of abstraction. Kaya principle of abstraction yung tawag sa kanya, or ganito ko siya tinatandaan. Kasi parang instead na ilista sila isa-isa, nagbigay tayo ng isang abstract concept o isang abstract notion na magiging criteria para maging member ng set na yon. Okay? Now, some examples is this. Set of all x's such that x is an integer divisible by 3. Set of all x's such that x is an ASEAN country. Set of all x's such that x is a positive integer less than 13. And sometimes we also put a generic criteria on the left side of the vertical line inside the curly braces. So this is read as the set of all real numbers such that x is less than or equal to 2. It can be observed that the first and the last sets are infinite. So hindi natin kayang isulat lahat ng elements sila in a roster method. But the sets B and C here are all finite sets. Okay. Now that's the principle of abstraction. And then mukhang everything is going well with this set theory. Actually, may isa pang axiom na ginamit si Cantor para mabuo yung kanyang set theory. It is called the axiom of choice. But the axiom of choice is a very important and more abstract, and it's more technical than the principles of extension and abstraction. Kaya i-discuss na lang natin siya in the next study guide. But those three principles or three axioms are the foundations of Cantorian set theory. Tatlo lang yung axioms ng set theory ni Cantor. Okay? And for 30 years, it seems that everything is going well until 1901. Dumating si Bertrand Russell, another great mathematician, a great modern mathematician. And he found an internal contradiction in Cantor's set theory. Okay? So, sabi nga natin, dapat walang contradictions dapat na manggagaling dun sa axioms. And yun na yung that's one of the make or break characteristic of an axiomatic system. Kasi nga, sinabi na ni Hilbert na kung meron kang consistent system, imposible siyang maging complete. So nag-give up na tayo na complete yung axiomatic system na mabubuo natin. Tinanggap natin na hindi lahat ng theorems ay provable within the axiomatic system, pero we will insist na consistent dapat yung axiomatic system. Dapat walang internal contradictions. However, Bertrand Russell considered this set. Okay? Sabi niya, okay, bubuo ako ng isang napakalaking set, si set A, na ang laman niya ay mga sets capital X, such that capital X is not an element of capital X. So sabi ni Russell, okay, so following Cantorian logic or Cantorian axioms, pwede kong sabihin na si set A, na ang laman niya ay lahat ng sets na hindi naglalaman ng sarili nila ay isang set. Okay? By the principle of abstraction. All right? So yung property P niya dito ay P about X is X not containing itself. Okay? At wala siyang na-violate dun sa mga axioms, alright? Dun sa mga rules na sinet out ni Cantor. However, there's a contradiction here. The question is, si set A ba ay laman ni set A? Okay? So yun yung pinag-isipan ni Russell. Ito yung proposal ni Russell. Okay? So, Cantor, ito yung sinabi mo. Ito lang yung requirements mo sa set theory mo. So, ibig sabihin, valid na set itong capital A. Set of all sets that do not contain themselves. Alright? Question. Si A ba ay laman ni capital A? Okay? So, kung si A ay laman ni capital A, ibig sabihin, pwede kong palitan yung X by A. Sasabihin ng condition si A ay hindi dapat laman ni A, which is a contradiction. Or, kung si A naman ay hindi laman ni A, so si A doesn't belong to A, then si A dapat mag-belong kay A kasi si A hindi niya laman yung sarili niya, which is basically property P that we made the criterion for membership to the set A. So, be it A being in A or A not being in A will produce a contradiction. Ito yung sabi ni Russell. So kulang yung axioms ni Cantor kasi nakakita siya ng isang example na hindi na magbibigay ng isang contradiction. Wala siyang violate dun sa mga axioms ni Cantor and yet there's a big contradiction in here. All right? Now, there's a more popular version of Russell's paradox. Ang tawag natin dito ay Russell's paradox. Medyo technical kasi yung Russell's paradox. So, yun yung Barber's paradox. Okay, so sabi dito, in a small town where every person is clean-shaven, then there is a barber. Nag-iisa lang yung barber dito sa town na to. Tapos, sabi nung council nung town na yan, ang pwede lang i-shave ni nag-iisang barber ay lahat ng mga hindi kayang i-shave yung sarili nila. So the question is, sinishave ba ni barber yung sarili niya? Or kaya niya bang i-shave yung sarili niya? Okay? So, meron dalawang possibility. Either sinishave ni barber yung sarili niya or hindi niya sinishave yung sarili niya. So, P or not P, tautology yon. Dalawa lang yung posibleng cases. Case number 1. So, kung sinishave ni barber yung sarili niya, so ibig sabihin, kaya niyang i-shave yung sarili niya, so him being the barber should not shave himself, making the barber somebody who doesn't shave the barber or himself. So, contradiction yon. Or, kung dun tayo sa pangalawang case, halimbawa, hindi naman kayang i-shave ni barber yung sarili niya. Kung hindi niya kayang i-shave yung sarili niya, dapat i-shave niya yung sarili niya kasi siya yung barber. At sabi ng council, kailangan mong i-shave lahat ng hindi kayang i-shave yung sarili nila. And that will put the barber in a big quandary. So, i-shave man niya yung sarili niya or hindi niya i-shave yung sarili niya, merong contradiction. Okay? And this simple scenario here broke Cantorian set theory. So, hindi pala consistent yung set theory na inimbento ni Cantor, even though it was already used in a span of 30 years. Most of the results were already established. Ginagamit na siya ng ibang mathematicians. Pero ito, nagkaroon ng problema. Hindi pala siya consistent. Gawa ng Barber Paradox ni Bertrand Russell. And so with this discovery, mathematicians strive to make set theory and the results of Cantor into something consistent. Kasi nga, maganda na yung theory na na-develop ni Cantor, there's just one big flaw to it. Hindi siya consistent. So, tinrayang remedyohan ng mga mathematicians and they attack the notion na masyadong lenient yung konsepto niya ng set. Kasi kung mapapansin nyo, yung dalawang principles na nakita natin, 2 out of the 3 principles, ay nakadepende lamang sa membership. Parang napaka-lenient nung axioms o nung rules governing memberships to a set. So yun yung tinry na remedyohan ng mga mathematicians in about 7 years after Russell put forth this paradox. Si Ernst Zermelo, he proposed a more axiomatized set theory that produces no contradiction. So tinry niyang i-develop yung set theory, nagdagdag siya ng axioms to the Cantorian axioms so that ma-avoid yung existence ng paradoxes. And then later, dinagdagan pa ni Abraham Frankel at saka ni Thorolf Skolem yung mga axioms na binigay ni Sir Mello. Kasi magkakaroon pa rin pala ng contradictions dun sa mga axioms na pinopose ni Sir Mello. And they made set theory a consistent system. And so kaya siyang tinatawag nating modern day set theory o yung Sir Mello-Frankel set theory. I don't know why Skolem was dropped from the billing. Bakit siya nawala dun sa attribution? Pero supposedly dapat siyang Sir Mello-Frankel Skolem set theory. But for due to some reasons, sige, i-research ko kung bakit, kung may issue ba sa pagitan ni Sir Mello at saka ni Frankel. Tama si Esther, naging et al na lang si Skolem. Pero I think almost equal yung contributions ni Frankel at saka ni Skolem dun sa additional axiom. Actually, they just added the axiom schema of replacement dun sa mga axioms ni Sir Mello. Pero nga, naging et al nga si Skolem. Sige, research ko kung bakit. Tingnan ko kung merong issue between them, kung bakit siya naging et al. But that would be our lesson for next week. Tingnan natin ano pala yung mga kulang na axioms na kailangan nating idagdag dun sa set theory ni Cantor. Actually, hindi lang pala idagdag kasi medyo flawed. Hindi pala medyo flawed talaga yung axiom of abstraction. Kasi yung axiom of abstraction niya gave rise to the existence of very big sets. Okay? Na pwede mong sabihin yung set ng lahat ng sets na hindi nila laman yung sarili nila. And that will imply the possibility of creating a big enough set to contain everything. All right? Kaya lang sabi nga ni Hilbert, may mga bagay na hindi posibleng magawa sa isang axiomatic system, and it turns out that it would be bad if we will allow the creation of a set that will contain everything. So yun yung trinabaho ni Sir Mello, and later dinagdagan ni Frankel at ni Skolem to develop what we know now as the modern set theory. The nice thing about this is hindi na baliwala yung mga results that were established using Cantor's intuitive or naive set theory. Ang naging dagdag lang ng mga axioms or naging implications ng axioms na binroach ni Zermelo, Frankel, and Skolem ay natanggal yung internal contradictions sa set theory. So tingnan natin next time ano yung mga axioms na idinagdag ni Zermelo, Frankel, and Skolem, and let's see what their implications are. Okay? So, do you guys have any question? Siguro ito na yung end ng medyo GE-like na introduction to set theory. Next meeting, we'll start talking more technical kasi pupuntahan na natin yung bawat isang result, yung mga axioms and then what their implications are. All right? Worksheet 7, binabrowse ko nga siya kanina bago yung start ng klase. Siguro let's postpone worksheet 7 na lang muna. If you are medyo tight yung schedule nyo. So trabahuin nyo na lang yung worksheet 6. The deadline for worksheet 6 is on Monday. But worksheet 7 can wait. Probably kung kakayanin natin ng Friday next week or siguro Monday week after next. Pero gusto kong makahabol tayo dun sa study guide. So probably I'll schedule worksheet 7 Friday next week. And then let's see kung matatapos natin yung susunod na worksheet, yung worksheet 8. Pero hindi ko nga natapos yung worksheet for this week or yung study guide for this week, but who cares, right? So mahalaga na iintindihan natin yung mga topics. All right, so any other questions, guys, aside from that? Okay. Kung wala, those are recited, please put your names on your nicknames on the chat. Medyo may backlog pala ako sa pagre-record ng recitation. Lahat ng recitation before yung last week before the reading break, hindi ko pa na-record. And that being said, yung standings nyo ngayon, makikita nyo na siya sa Canvas. So nakadepende siya kung ano na yung mga na-checkan. kinompute ni Canvas yung standing nyo, yung midterm standing, based sa kung ano yung na-checkan ko na at na-checkan na ng lab instructors nyo. Kung hindi pa na-checkan ng lab instructors nyo, meaning hindi pa siya factored in, hindi siya kasama sa computations, binawas siya sa denominator. So you can check your midterm standing in Canvas. Ba't ko nga siya nabanggit? Ayan, wala ako. Nakalimutan ko yung gusto kong sabihin. Let's see. Yeah. Nakalimutan ko yung gusto kong sabihin. Sorry, guys. Bakit ko nga ba binrought up si Canvas? Meron akong gustong sabihin na wala lang sa isip ko. But, okay, it is what it is. So, sana maalala ko later. But that's it for now. Thank you guys for coming. Enjoy the rest of your day. And as always, let's see each other again next week na pala. All right. Bye, guys.
Thank you po, sir.
All right.
Thank you, sir.
Yun